Okay, so we're going to compare and contrast this stuff. So what's the first thing that we notice? Well, we notice that some of the letters repeat, right? We got this A and this A. Well, we know that A is the amount of medicine, right? We've also got this 20. And we know that from our talking about exponential functions, this 20 is going to be our initial amount. Okay? We've also got this 8. Okay, so negative 0.8 is going to be our rate. And the reason why I know that is because if I have this as my function, then r is going to be that value that's multiplied by t, which is just going to be your time. Now, ln and e are inverses of each other. Okay, so ln and e are inverses of each other. So if I were to take this guy over here and actually solve, then this is what it's going to look like. I've got a equals 20 times e to the negative 0.8 t. I'm going to divide by 20 on both sides. And so a is going to be divided by 20, which is going to equal e to the negative 0.8 times t. In order to get rid of that e, I'm going to multiply by, or take the ln of both sides. When I do that, this cancels. And so I'll have ln of a divided by 20. And then I'll divide by negative 0.8 on both sides. And I get this. Okay, I know easier said than done, but that is how you would go about doing this one. Good question on that one. So why does ln cancel e? So what's going to happen is ln is actually log of base e. Do we agree? Hopefully yes. Okay, so if I take the log of base e of e, then that would mean that I would put in my calculator log of e divided by log of e, which is just going to be 1, right? Okay, so that's why it can cancel it out. It takes everything that's up in this exponent and brings it down, because you can do the change of base formula with it. It's kind of like if you had log of 10, okay? This is going to give you, or if we have 10 to the x power, if I take the log of it, that's just going to leave me with x. Okay, so there are inverses with the exponential functions, and then the logs. Those are inverses of each other. They kind of cancel each other out. All right, so we're going to take this function, and we're going to put it in exponential form. So that was the first thing that we learned how to do in this unit. So remember, we always start with our base, we go to our outside, and we finish here. So base raised to the exponent equals our solution. So my people who are visual, log of your base of your solution equals your exponent. Okay, also known as base raised to your exponent equals your solution. Okay, these are the same things, just written as a exponent, written as a log. Now, if I were to go about solving this problem, obviously I know that 2 to the second power is going to be 4, right? Like I know it's going to be 2. But let's say that I didn't know that. Then what I would do is I would take this original and I would do the change of base, which means that I'm going to take the log of 4 and divide it by log of 2. And if I put that into my calculator, I get 2. All right, so on number 2, we're going to put it in exponential form. So we're going to start at our base, go to our outside, finish here. So 5 to what power gives us 125? Now, I'm going to be honest, I don't know this off the top of my head, right? So then what I would do in order to solve is I would do the change of base. So I would do log of 125 divided by log of 5. Okay, and if I didn't have my calculator, I would go into Desmos. Go into the graphing calculator. And do the log of 125 divided by log of 5, which is going to give me 3. Coming back over here, this is going to give me 3. So there's a problem that's very similar to this. We've got 2 to the second power equals 8 to the 3x plus 1. Okay? And back in Algebra 1, you learned something very, very similar to this. You just didn't really deal with like really high powers. So, for instance, I can't set both of these exponents equal to each other because my bases aren't the same. So is there a way to write base 2 in terms of 8? So basically, 2 to what power would give us 8? Well, 2 to the third power would give us 8, right? And then I rewrite everything else the same. Okay, so instead of this just being 8, this is going to be 2. But now that it's 2, I can cancel my bases, and I can set my exponents equal to each other. So this is very much like our property of logs, where we have the same base for the logs, and then you can set each of them equal to each other. Same properties, same way it works. So now we just solve. So we'll distribute this, and we'll get 9x plus 3. We'll subtract 3 from both sides. And so x is going to equal negative 1/9. Okay? One other thing that I do want to mention is ln and e. I know we talked about this a little bit, but if I have e to the 2x power equals 7, and I want to take this and write it in log form, I'm going to go from e to 7 over to 2x. So this is going to be log of base e of 7 equals 2x. Another way to write this would be ln of 7 equals 2x. If they ever ask you for the inverse of a function, so like let's say they gave you y equals log of 2 of x, and they said find the inverse, they're talking about putting it in exponential form. So you're going to go from 2, go to the outside, and finish over here. So 2 to the y equals x. Okay, and just be mindful of like how you write it. Just be mindful of it. Okay. All right. Are there any questions?